This is question number 16 on the January 2017 Algebra 2 Common Core Regents, and this is an exponential growth and linear decay or linear decrease question. So we have Pedro and Bobby each own an ant farm. Pedro starts with 100 ants and says his farm is growing exponentially at a rate of 15% per month. Exponential growth formula is P equals PO, 1 plus R, because we're growing at a percentile. We used just R here before. That's because we were given a double. So I just put in a 2 to make it easier because it would be doubling every time period. And this all raised to the T. You may also have seen this as this. This is more applicable in finance because A represents amount and P represents the principal. This is more applicable for population because PO represents initial population and P represents the population at time T. Either way is fine. They're exactly the same formula as long as you put in the correct numbers. So let's do Pedro's calculation. His population will be 100 ants times 1 plus the rate. We have to convert that rate to a decimal, so 0.15 to the T. And then Bobby starts with 350 ants and says his farm is steadily decreasing by 5 ants per month. So this is a linear because we're losing 5 ants every month. So Bobby's population would be 350 ants minus 5T. And you could use M here if you'd like for month. It doesn't make that much of a difference. But the idea is that we are decreasing by 5 each month. That is a linear decrease, meaning it'll be 345 after 1, 340 after 2, etc., etc., etc. So, conveniently enough, P, population, would also be okay to represent Pedro here. B, Bobby's ant farm, 350 minus 5T. And the question is, assuming both boys are accurate in describing the population of their ant farms, after how many months, that means we're asking for T, will they both have approximately the same number of ants? So P equals B. So all we have to do then, since P equals B, is set P equal to B, or the equivalent equations. 100, 1 plus 0.15 to the T equals 350 minus 5T. Now, doing this by hand is somewhat tedious. So we're just going to go ahead and do this in the calculator and graph these two equations and see where they intersect. So let's go to y equals. Clear what we have in there now. And we'll put in 100 times 1 plus 0.15, or you could just do 1.15 to the x, and then 350 minus 5x. And we can graph this. Now, this is not going to show up on this particular graph in this spot because, well, my window is very, very small. This is just from about -2 to 2. So we're going to zoom out. And we're going to repeat that until we can see both graphs. Now you'll see at this point they're somewhat difficult to see. They would probably intersect somewhere up here. So we could also try another zoom, which is zoom fit. And we still don't really see the other graphs. So our best bet here is going to be to play with the window. So we're not interested in negative time, so we'll start the x, the time, at 0. And what we're going to do is we're going to change the x max to, well, let's see, the maximum month here appears to be 36. So let's go to like 50. And the y min we're going to go to is going to be, well, again, we're not interested in 0 ants or below that, so we're just going to make that 0. The y max, well, we started at 350 ants, so we probably don't need this massive number that the zoom fit created. So why don't we change this to, oh, say around 500? Because we know that Bobby started with 350 ants. Now we've got a pretty decent graph. And we see a very clear intersection point. So we will use our second trace calc feature to find the intersection. We've used this once before in an earlier video. And remember, we did say that this calculator is pretty good at finding the first curve and the second curve. And the guess is irrelevant, so you can just let the calculator do the work. And we've got an x of 8.08. So that's about 8 months. Let's say you have trouble getting the zoom correct, which wouldn't be an uncommon problem. We can actually just put in each of these values, the 7 and the 8 and the 13 and the 36, into the calculator for both equations and see which ones match. We could also use the table. The table of values will tell us approximately where they're going to be the same. So if you look at 0 months, our first equation is Pedro's exponential. We have 100 and Bobby's got 350, which makes sense. Pedro starts with 100 at month 0. Bobby starts with 350 at month 0. And we can scroll down until the numbers are pretty close to the same in the two functions. At 7, it's still not quite there. At 8, they're pretty close. And if we go all the way to 13, now we've got a big spread again. This time Pedro is going to have a lot more ants in his ant farm. So 8, 305.9, and 310, that means our answer is going to be somewhere near 8. So that is also acceptable, especially if you have trouble getting this kind of shape on your graph, which, as we saw at the beginning of this video, is not unusual. That is a difficult thing to properly graph because none of the standard zoom features will really give it to us. So here you have it, two different ways to approach this question. Even a third way if you want to just sub in the 7 into each of these and the 8 into each of these t's and see which ones give us the closest value.